Hi everyone, so in this video we're going to be using the properties of inverse functions to find the exact value for certain function compositions. Now let's go ahead and begin with the first problem where we have, suppose that the angle theta is given by the sine inverse of 2/5. Now we want to go ahead and use this information to figure out, okay, well, what would be the cosine of theta and what would be the tangent of this angle theta. Now the way that I would recommend working with these problems is to simply go ahead and draw a triangle using the given information to find the remaining unknowns. Now what I mean by that here is, notice what they're giving us. They're giving us that the angle theta is equals to the sine inverse of 2/5. Now what can we do now? Well, I mentioned we have to draw a triangle. That's a recommended approach, but where is a triangle? Well, notice that we can go ahead and take the sine of both sides, which will allow us to cancel the sine and the sine inverse, and we're left with the sine of theta is equals to 2/5. Now, based on the definition for the sine function, we know that we could rewrite it here as a ratio of the side opposite, the y, over the r. Now, at this point, you might be thinking, okay, well, we can set up a triangle now, but how will the triangle look like? Will it be a triangle in the first quadrant, or would it be a triangle in the second quadrant? Because it seems like all we know so far is that the y value is 2, and the hypotenuse is equals to 5. So which quadrant should we select? Well, lucky for us, there is only one triangle that can be created. Because if you recall, if we are using an inverse sine, then that means that this angle has to be between the negative pi over 2 and the pi over 2, which, as we discussed in the previous videos, that restricts our quadrants to only quadrant 1 or quadrant 4. But we know we cannot select quadrant 4 because we are getting a positive y value. So that means that our only choice is the first quadrant. So now you see here that, okay, well, we have our triangle with a y value of 2, and since we're being asked to find the cosine and the tangent, well, we still need to figure out, okay, well, what will be the x value? What's the length of the side adjacent? Well, in order to figure out the x, we need to remember that since we are dealing with a right triangle here, so we can go ahead and use the Pythagorean theorem. We know that r squared is equals to a squared, or in this case, x squared, plus y squared. Okay, now putting everything together, we know that r is 5, so that means that we have 25 is equals to x squared, plus the y being 2, so 2 squared is 4. Alright, so isolating the x squared, we get that x squared is equals to, seems to be 21. Take the square root of both sides, take the square root of both sides. Now remember, normally when you are taking a square root, we need to include the plus or the minus. However, because we do know that we are in the first quadrant, then we're only picking the positive value. And it seems like x is equals to the square root of 21. Alright, so now that we know what the x is, we have the missing piece of the puzzle. Now we can go ahead and figure out what will be our cosine value and our tangent value. Well, I'll write it here as the cosine is equals to, well, let's here put cosine of the angle, is equals to x, so it's rad 21 over r, so it's over 5. Now the tangent of the angle theta is going to be equals to the side opposite, the y, over the adjacent. Alright, now rationalizing that denominator, we're going to get 2 rad 21 over 21. And that's it. So this is typically the strategy for this type of problems. Go ahead and take the angle, be aware of the restrictions on that angle, take the sine of both sides or the cosine or the tangent, whatever the case may be, so that you're able to create your triangle, find out the missing side, and then figure out the remaining trig functions. Alright, now let's take a look at a very similar problem. So the next problem here, example 6, is asking us to find an alternative form for the cotangent of the cosine inverse of x over 4. Now I'm going to go ahead and use a similar approach to what we did above. Now remember that what we are given here, we're being given the cotangent of a certain angle. So I'm going to say that this one here is our angle theta. Now recall here that the conditions for you to be able to use the cosine inverse is that the angle itself has to be greater than or equal to 0 and less than or equal to pi. Okay, so now I'm going to go ahead and rewrite here theta as the cosine inverse of x over 4. And just as we did above, I'm going to go ahead and get rid of the inverse function by, in this case, taking the cosine of both sides. Alright, so we get to see here that the cosine and the cosine inverse cancels, and we're left with the cosine theta is equals to x over 4. Okay, so now that we have the cosine theta is equals to x over 4, we get to see here that, okay, well, we have the cosine as a ratio of x over r, and now we see here that, okay, it seems like the r is equals to 4. Now, just as above, we're going to go ahead and create a triangle. Alright, so now the x here is a positive cosine. The r was 4, so we're once more working with our first quadrant. So we're going to have here the r being 4. We got our x here. And our y value here. Now it's okay if we don't know the y value, guys, because remember, we're trying to rewrite the expression in terms of x. So with what we have so far, using the Pythagorean theorem, we're going to have here that r squared is equals to x squared plus y squared. In this case, the r is 4, so we're going to have here x squared is equals to 16. Alright, so isolating the y, we have here that y squared is equals to 16 minus x squared, taking the square root of both sides. And again, whenever you take the square root, you have to include the plus or a minus, but in this case, because we know we're in the first quadrant, then we're going to have here that y is equals to the square root of 16 minus x squared. Alright, so now that we have the missing side for the triangle, we can go ahead and figure out the cotangent. I'm just going to move this further up here, and we're going to have here that the cotangent of the angle theta, given by the cosine inverse of x over 4, is going to be equals to, now recall here that the cotangent is equals to x over y, but now that we have the y, we're going to have here that the cotangent of the angle theta here is equals to x over the square root of 16 minus x squared. Okay, so this is it for this set of problems. And again, guys, they are very similar. We have to draw a triangle that simplifies the process quite a bit. So we're going to be putting a stop here, and now we're going to be switching gears and focus on derivatives in the next video. See you there.